I welcome you to this lesson. I am teacher Katimbo Richard, teaching mathematics. In this class, P4, remember we started term 2 work, which term 2 work we are continuously looking at. Only that today I've come with a new topic known as geometry. What you need to have is what is called a set of geometry. This is what's called a geometry set, which geometry set must be full of all the instruments that you bought it with. So it must not be empty by virtual instrument. So and these are the instruments you must have. This is a ruler which is going to be used to draw straight lines, not crooked ones, as well as measuring the drawn lines. This is what's called a ruler. Ensure it is not lost. If lost, then you will have lost the key instrument or one of the key instruments in as far as geometry is concerned. Then we shall have this protractor. It's called a protractor, and it's used to measure angles, like we shall see. We shall use it to measure angles. It has what is called a pair of compasses, within which we fix the pencil in case you are asked to construct any angle. So this is what's called a pair of compasses. And then we shall have another one which is called a pair of dividers, which is used to mark some points on the drawn lines, and then that dimension taken to a ruler to measure that marked kind of dimension on the line segment. So we shall have to see how useful the dividers are. This is a pair of dividers. And then we've got these triangular ones, which are called set squares, much as they are triangular. They are used in drawing parallel lines along with a ruler, as we shall see. Then we shall have the rubber used to erase in case you made a mistake in among the lines you have drawn in pencil. Please, this is the rubber. And then the sharpener, which is used to have a sharper pencil than how we bought it. Please use to sharpen the pencil. That's what's called a sharpener. So those are the real instruments that are bought within the geometry set that you are going to use in this geometry as a topic, and then you reach perfection. The work teacher is discussing will be found on page 32 of our P4 term 2 workbook, and all the way to page 37 for this particular lesson. Ensure I open page 32 of the workbook of our P4, you will be able to answer. And now you will see teacher using such instruments here, and then you will wonder, don't go to the shop and buy such a ruler for you to use during examinations or on paper or in your books. Don't. We use the other ones that are bought within a geometry set, and then you use them. So these are like board ones, the white board ones, the black board ones, or any board, so that they are dummy ones for you to see exactly what you are going to do on the real rulers or the real instruments that are supposed to be used. So this is called a ruler that I will use, but for you don't use it. This is called protractor, which is used, like I said, to measure angles. This will be my pair of compasses that I'll be using to draw circles as well as constructing different angles, like we shall see, and the set square as well, which is used to draw parallel lines along the ruler, like we shall see. So, those are the instruments that you are required to have in this geometry, without which you will not go the practical way of geometry. You stop at the theory. Normally we start with the theory, like you are given in P4. Sorry, that like we are here in P4. We are being introduced to those geometrical instruments. Now we start. Now we start with drawing and naming different shapes. Drawing and naming different shapes. So the shapes are here. They will tell you the space below. Draw a rectangle. A rectangle looks like what you are seeing. So it's a four-sided polygon with the two opposite sides equal and parallel. So here we show that this side is equal to this side. These ones mean they are equal, whereas here you put 1, 1, meaning this width is equal to width, the length is equal to length, and the width is equal to width. So be careful about how we show these ones. So here we put 2 and here 2 for the length. The two lengths are equal. These are called length. These are called widths. So the two widths are equal. In short, it's four-sided polygon. As look at the square, this is what's called a square. A square is a four-sided polygon, or is one of the quadrilaters, because any four-sided polygon is called a quadrilateral. Is one of the quadrilaters with all sides equal, as opposed to rectangle. A rectangle has got only two opposite sides equal. This is equal to this, and this is equal to this. Whereas here, each of the sides is equal to the other. That's why we draw in a different form. To show that all sides are equal, we put 1 to mean all are equal. Whereas here we say 2, 2, 1, 1. So here, 1, 1, 1, 1. All sides are equal, and all angles are right angles, like a rectangle is. So this is called a square. Then a kite is also a four-sided polygon that is actually built into two, or separated into two different isosceles triangles. So these two triangles, when joined together, look at the downward triangle and the upper triangle. So when we've got two different isosceles triangles where they have got two opposite sides equal, this side is equal to this side, and this side as well is equal to this side. Note that all sides are equal. Here I've got 1, 1, and here 2, 2. So that is what's called a kite. Draw a kite in that way. Sometimes they put in these lines, but you are required not to. So they're just helping you to know that there are two different isosceles triangles. But now this is what's called a kite, and draw it like that. Then I've got a trapezium. A trapezium is a four-sided polygon with only two sides that will never meet, which we call parallels. So it's drawn like this, like you see it is drawn. This side will never meet this one, even if they are prolonged further, meaning they have got, or it has got a pair of lines that will never meet. Lines that will never meet, that you will find to be parallel in P5 and 6. But here, draw a parallelogram, draw a trapezium like that. So then we go a rhombus. A rhombus is like a pushed square. It has got all sides equal, but bent. So it has got all sides equal, where two of them will never meet. So these arrows mean these sides will never meet, these alone, and these two will never meet. Put one arrow, and then show that all sides are equal. Like I say, it's like a pushed square, and then it is a rhombus. Then a parallelogram for this like a pushed rectangle. It's a rectangle, when you push it like this, you come up with a parallelogram. So it has got almost the same properties like a rectangle, where two opposite sides are equal and parallel. Two opposite sides are equal and they never meet. So here 2, 2, 2, 2 meaning this side is called that side. These two arrows mean these two will never meet. As we go, this side or these two sides, where this side is called that side, and still they will never meet. They are parallel. So that is a parallelogram. Then an oval is almost like a sphere. So let it be like an egg. The egg is in the oval style. So an oval is drawn like an egg. It's not a real circle like you see an egg. You draw something like that, and then you'll be perfect in drawing shapes. So when you're taught to draw shapes, please look not further than these ones I've given you. Please draw them properly, and then we look at parts of a circle. A circle, like you see, is a round object. A round thing is called a circle. Then we shall look at lines of a circle. You will see this line, this line, this line, and that line. So a line drawn from the wall of a circle, sometimes called circumference, through the middle of a circle to the wall is called diameter. That we shall see the spelling. This is called diameter. From y to x, line xy or yx is called diameter. Then a line drawn from the wall of a circle called circumference to the middle of the circle is called radius. So this line is called radius. That is RO. Line RO is called radius. Line RO is called radius. Please, line RO is called the radius. So look at the radius here. Line RO is called radius. And then a line that's drawn from the wall of a circle, not through the center, like you see this one, which is not passing through the middle or the center, but goes to the wall or the extreme wall, the other side, is called a chord. Sometimes called chord, but it's better to say chord. So line PK is called a chord. It's called a chord. Now, line MO, now that's coming or starting from the wall of the circle or from the circumference to the center, is called radius. So you will be required to name the lines. Like you see here, we are saying name line PK. Name line PK. Look at PK. I say it's called a chord because it doesn't pass through the center but connects to the wall of the circle, wall to wall, but not through the center. From circumference to circumference, but not through the center. That PK is called a chord. Look at the spelling, C-H-O-R-D. C-H-O-R-D is the word chord. Then name line OY. Go back and see. We've got O up to Y. So a line going from the wall of a circle or from circumference to the center is called a radius. So line OY is called a radius, R-A-D-I-U-S. As you are going to name line XY from X to Y through the center. A line going from the circumference through the center to the circumference, or from the wall of a circle through the center to the other wall, extreme wall, is called a diameter. Look at the spelling of diameter. D-I-A-M-E-T-E-R. D-I-A-M-E-T-R. That is the diameter. So those are lines of a circle. Then we look at the two parts of a circle. When a circle is cut into 4 equal parts, each part is called a quadrant. When a circle, if I've got a circle and then you cut it into 4 equal parts, This is called a quadrant, a quadrant, a quadrant, a quadrant. A quadrant is a quarter of a circle. A quadrant is a quarter of a circle. So when a circle is cut into 4 equal parts, you get what is termed as a quadrant. So a quadrant is a quarter of a circle. Then we go to a semicircle. When a circle is cut into 2 equal parts, so each of the 2 parts is called a semicircle. Look at the spelling. Semicircle. Semi. Between semi and circle, put a hyphen. So spell S-E-M-I hyphen. It's like a minus. Then circle, C-I-R-C-L-E. Then quadrant, Q-U-A. D-R-A-N-T. A quadrant is a quarter of a circle, whereas a semicircle is a half of a circle. How do we reach a quadrant? When we divide the circle into 4 equal parts. How does one reach a semicircle? When one cuts the circle into 2 equal parts. So each part is called a semicircle. Now we have reached use of our geometrical instruments. Now drawing a circle or drawing circles. Example number 1 says, draw a circle of radius 4 centimeters. Draw a circle of radius 4 centimeters. Now, you must learn on your very ruler how to measure the said radius. You go where centimeters are. This is cm on your ruler, not this one, mine. Then, put your pointer of the pair of compasses at the beginning here, where centimeters are. You see cm and 0, and then put it there. Put your pointer here, and then adjust to 4 centimeters. Adjust to where 4 is. Let the pencil point at 4 like this. That will be the radius. So if you have done it, then you feel perfect. So ensure I measure well, and then you will be able to draw that circle. So I've measured my 4 centimeters properly, and then I'm going to draw the required circle. I position my pair of compasses properly on my book. Ensure it is stationary, doesn't move at all, and then freely make a circle. You are going to freely make a circle. Ensure your pencil is sharp, very sharp, and then draw a circle freely. You hold that pair of compasses to the top as you draw the circle. We are about to draw. Now I'm going to draw. So draw the required circle. Ensure this does not move. If it does move, you have lost the battle of champions. Ensure it does not move. For when it moves, you will not draw a proper circle as required. Now the eraser did not do well. Avoid rubbing. So the fact being that mine moved, it made a little error here. So if it doesn't move, you will be able to draw the required circle with ease. That is the circle that you are required to draw. Ensure the point of the pair of compasses is centrally placed without movement. You only draw that circle. Having measured our 4 centimeters, then we remove our pointer of the pair of compasses. Get a ruler. Don't use wrong tools. This is what's called a ruler. Ensure you use the one you have in your geometry set. Then join from the wall of the circle circumference to the middle, So that's what's called the radius. Remember I told you about radius? And say, I'm very sure I measured my 4 centimeters. And this is my 4 centimeter radius. And so doing, my circle is fully done. My circle is fully done. That is what we call drawing a circle using a pair of compasses and having measured the 4 centimeters. So do that for all the radii. Plural of radius is radii. So all the radii, all the kind of radiuses you are going to be given. So if it is 5 centimeters, measure 5. If it is 3 centimeters, measure 3. So this is the radius we are talking about from the point of the pair of compasses to the pencil. That distance will be making the radius measured properly, and the real radius is within the circle. That is from here, from the middle to the circumference, which is 4 centimeters. As we go to another practical number here, the given radius, let us see number 2. Draw a circle of diameter 6 centimeters. Draw a circle of diameter 6 centimeters. You are given diameter. Remember when we were learning here, we found out that diameter is a line drawn from the circumference or from the wall of the circle through the center to the wall. Whereas radius is from the wall of the circle to the center. Meaning, 2 radiuses make diameter. And when you are drawing a circle, ensure you have the radius, the journey from here up to here on the pair of compasses will be determining the radius of the circle. Now that you are given diameter, the question reads, draw a circle of diameter 6 centimeters. So, do you first get the radius? You never draw using diameter, use radius. Now, since 2 radii make diameter, then radius is equal to diameter divided by 2. Radius is equal to diameter divided by 2. The whole line from here up to here will be called diameter. So it will be 4 plus 4, which will make 8. So if I had been given 8 here, we will first divide 8 by 2. So that we first get our 4 centimeter radius, and it's the one we measure. We always measure the radius on the ruler. So we say radius equal diameter divided by 2. Now that the diameter is given as 6 centimeters, you say radius equals 6 centimeters divided by 2. So where 6 divided by 2 gets 3 centimeters. So our radius will be 3 centimeters. We go back and measure our 3 centimeter radius. We adjust up here. So 3, you see where 3 is on our ruler. And then we shall be perfect. Like I've measured, you confirm on the table and draw as required. You get our 3 centimeters properly and then answer accordingly. Now you are going to draw our circle, which you have measured 3 centimeters for. So we centrally put our pointer. Ensure you don't put a hole in the book or on paper. You freely make that circle. You freely make that circle. Let the circle be drawn. Having measured the 3 centimeters, ensure you're accurate in the measurement. Ensure you have taken that measure on the centimeter scale. Draw the circle freely, and then you reach the perfection. So this is our circle. Now that the circle is finished, you remove the pointer of the pair of compasses. This time around, they are saying, draw a circle of diameter. So since the radius was 3, now remember we measured 3, but now draw the whole diameter as dictated by the examiner through the center of the circle to the circumference. I said use a ruler through the center to the circumference. Draw thin lines, not thick lines. Ensure to thin, and then we label our 6 centimeters, and then we call it diameter. Remember our radius was stopping in the middle or at the center, whereas this is our diameter. So that is how we draw a circle given diameter. First work out the radius. We measure the radius on the ruler. Draw the circle using that radius. Then label the said diameter of 6 centimeters. And that's how we draw the circle using radius of diameter as given there. Ensure for the diameters given, first divide them into 2 equal parts, and then measure that radius, and then later show the whole line called diameter from the wall to the wall through the center of the same circle. Now we have another subtopic saying finding radius and diameter. Now you are going to be given any of the two to ask for the other. Like the example number 1 reads, find the radius of a circle whose diameter is 12 centimeters. This time they are asking for radius, like we've done up here. Radius equal diameter divided by 2. Radius is equal to the diameter of 12 centimeters divided by 2. Cancel or divide by 2. 2 divided by 2 once, 12 divided by 2 gets 6. Our radius will be 6 centimeters, like we did up here. Then we go to example number 2, says, find the diameter of a circle. This time we are finding the diameter of a circle whose radius is 3 centimeters. Remember 2 radii or 2 radiuses make diameter. So diameter is equal to radius plus radius. So diameter equals our radius of 3 centimeters plus another radius of 3 centimeters. So diameter equals 6 centimeters. Like you saw here, we measured 3 plus 3 gets 6. So the diameter is 6 centimeters as we go along. So look at that exercise that concerns that when you are given radius, when you are given diameter to get the radius, you get the diameter divided by 2. You get the radius. Then when you are given radius to find the diameter, you find you say radius plus radius. You add those 2 radii and get the said diameter. Now we go to our algebra and geometry, or finding the unknown angles. Finding the unknown angles. Finding the unknown angles. This is the way we find the unknown angles. Now look at this and see how we find the unknown angles. We start. Find the value of the unknown in each of the following. I've got part A with this diagram. When I've got this diagram and I've got this angle, that's called a right angle. A right angle is equivalent to 90 degrees. So, however many the subdivisions may be, they all add up to 90 degrees. That's why we say m plus 60 degrees is equal to 90 degrees. Then you work out, when you are being given a plus, or you are formed using a plus, you subtract that added number 60 from both sides. You say m plus 60 degrees minus 60 degrees equals 90 degrees minus 60 degrees. We know 60 minus 60 is a 0, so this side you have got m, where 90 minus 30, subtract 90 minus 60, you will get 30 degrees. So m equals 30 degrees. I said when you are given a number like this, these are right angles. Right angles add up to 90 degrees. So we say this is what's called a right angle. So now m plus 60 degrees is equal to 90 degrees. It's the one you form here. And I said when you put a plus sign here in your algebra, you introduce a minus sign in the same algebra and say m plus 60 degrees minus 60 degrees equals 90 degrees minus 60 degrees. Now that you have subtracted 60 and 60, 60 minus 60 you get a 0. This side you have got m, and 90 minus 60 you get 30. If you don't know that, put a side work, write our 90 degrees minus 60 degrees. You will then subtract normally. That 0 minus 0 is a 0. 9 minus 6 is a 3. Thereby getting 30 degrees. So m equals 30 degrees, and that is the answer. Likewise in part B, it's the same figure with the right angle, all angles on right angle. When you see a box like this, they add up to 90 degrees. So we say k plus 35 degrees equals 90 degrees. You say k plus 35 degrees minus 35 degrees equals 90 degrees minus 35 degrees. Put a side up to add downwards or vertically 90 degrees minus 35 degrees. 0 minus 5 is only possible after borrowing. We borrow a 1 from 9, remain with 8, and the 1 is equal to 10. 10 plus 0 we get a 10, 10 minus 5 we get a 5, and 8 minus 3 we get a 5. So this side we have a k, so which k equals what I've got here, 55 degrees, and that's the answer. Then part C, you'll have the same diagram, the right angle. Do the same, angles on right angle add up 90 degrees. That's n plus 70 degrees, like you see, equals 90 degrees. Doing the same way, n plus 70 degrees minus 70 degrees equals 90 degrees minus 70 degrees. Where 90 minus 70 will get 20 degrees. This side will remain with only n, because 70 minus 70 is a 0. So we have n only, so n equals 20 degrees. Then finally, we've got part D. Still, angles on the right angle add up to 90 degrees, but this time there are 3. D, 25 degrees and 50 degrees. So, form using all the 3. D plus 25 degrees plus 50 degrees equals 90 degrees. Then you add 25 plus 50, you get 75. So I've got D plus 75 degrees equals 90 degrees. Then you go D plus 75 degrees minus 75 degrees equals 90 degrees minus 75 degrees. Then subtract your side work, 90 degrees minus 75 degrees. So I've got 0 minus 5. Possible after borrowing, we borrow 1 from 9 and remain with 8. Which one is equal to 10? 10 plus 0 is the 10. So that's 10 minus 5 is the 5. Here remained with 8 when we borrowed. 8 minus 7 is a 1. So 90 minus 75 get 15. So that our D is equal to 75 degrees. All in all, you must know that angles on the right angle add up to 90 degrees. And I said this work in your P4, that's geometry, will be found on page 32 all the way to 37 for this particular lesson. But geometry continues in the next episode after this one. But here, this one has covered all the work from page 32 up to 37. Please download it, play it over and over so that you can answer all the questions concerning the same work. Teacher Katimbo Richard. For more information about what I've explained or what I explained before, or mathematics in general, please call this same Teacher Katimbo Richard on 0776 251655. If not that, you can use the Airtel line, which is 07572 33066. Otherwise, stay safe.